So for this section, we are going to begin by talking about what a function is, and before we've got a few definitions to go over before we look at some example problems. So we're going to start talking about a function. So a function is where there is only one x value that corresponds to a y value. Okay, again, basically for every x value on our graph, there is only one corresponding value, y value. So anytime we have a point where we have the same or two different y values for our one single x value, that's a problem. We're going to looking at that as a graph. The easiest way to test this is what we call using the vertical line test, and that basically means for every vertical line the line only hits the graph or touches the graph one time. And that means every single vertical line that you can possibly draw, it would only touch the curve of the graph one time. So if I look at this first example here, I have this parabola or U-shaped graph. The easiest way to think about the vertical line test is if you take a piece of paper here, and I've got it, and you start over here on the left hand side and you kind of sweep it across. At any point in time, my piece of paper is only touching my graph one single time as I go completely across the graph. And so this particular graph is a function. But if you'll notice this other graph here, which is a circle, if I take my piece of paper again and I start moving across, you'll notice right off the bat, if I were to draw a line right here on my vertical line, notice that it hits the circle two times. And because it's hitting the circle twice, that means for this one x value where I drew my vertical line, it has two corresponding y values. So this would not a function. Okay. Again, drawing that vertical line across, if we can draw the vertical line across our graph and it never touches our graph more than one time, then that graph would be a function. If I draw that vertical line at any one given point, doesn't have to be more than one, but if I have one line where my graph touches, or my line touches my graph twice, then that's not a function. So the next thing we're going to look at is the domain. So domain are all the x values that are used in the function. And this is a not technically a very mathematically correct definition, but it's the easiest way for me to talk about this. So what I want to do again is I'm looking at that same parabola or U-shaped graph, and I want you to remind you that as I go off the graph here, that I have an arrow, so my graph continues to go off this direction, it continues to go off this direction. So remember that our x values are all the values along this x-axis. That's our x-axis. So what you want to think about when you're talking about the x values is if I start at 0 and I work my way this way, if I were to draw lines up, would I eventually hit the curve of my graph? And as you can see, even though I go off my graph, if I continue to go out to the negative side here, I will always hit my graph. So therefore, all of these x values have a value on our graph. The same thing is true if I go to the positive again, because remember that this line is going to continue on forever, so it's going to continue out this direction. So I have all of these x values all the way out to positive infinity also have value on my graph. So here for my domain, of this graph, I would say that it is all real numbers. Okay? Now, for our circle, it's a little bit different. You can see from looking at our circle here, now I'm going to switch colors. Again, I'm looking at my x values, but my circle ends right here. And then it ends over here, right here. So my domain on this guy is not going to be all real numbers because my circle only goes from -1 to +7. So when we write our domain for this guy, it would be from -1 to +7, and we're going to use closed brackets in this answer because we do have a value on our graph at -1 and we have a value on our graph at +7, and that's what those closed brackets mean, if you'll remember from when we were graphing inequalities. Okay, so for our range, we're looking at all the y values that are used by our function. So very similar to our domain, except now we're looking at what values are used along our y axis, or our y here that I've highlighted for you. Now notice that when we look at our graph, as we go down to to the negative values, notice that our u stops here at this value right here, which is -3. So it doesn't go any lower than -3 on our y-axis. But as we continue up and looking at our positive, since our graph here has an arrow, it's continuing to go up as far as the arrow goes, and that's going to go to infinity. So when we look at our range for this particular graph, it would start at -3. Again, we're going to use a bracket at -3 or a closed in parentheses because we actually have value on our graph at -3. And then it's going to go all the way to positive infinity, and since it's going out to positive infinity, that's going to be a parentheses. Again, looking at the same thing for our circle. Again, remember we're looking at the values that are being used on our y-axis. So we're looking from bottom to top of our circle. Notice here that our circle stops down here at the bottom at -9, and up here at the top it stops at -1. So our range for our circle is going to be from -9 to -1, and we're going to use a closed bracket on both sides of that. Again, we're using a closed bracket because it has value at -9 and at -1. I also want you to notice that the -9 came first because he is the smaller of the two values, and whenever we write our interval notation, we always write our smallest value first. Okay, so for our first example here, we're being asked, this is 2 steps. The first question that we're being asked is, does this graph represent a function? So remember, function is our vertical line test. So if I take a piece of paper again, and I can start, doesn't matter whether I start from the right or the left, but if I sweep my piece of paper across my graph, does my edge of my paper only touch my graph one time as I go across? And notice that it does indeed only touch it one time. So yes, this graph is a function. Now for our domain, again remember that domain are your x values. So I'm looking across this way, and I want to again remind you, as my arrow goes out this way and this way, it's continuing on forever. So I want you to think about, as I'm going to the left and this arrow keeps dropping and dropping, I'm continuing to have value over here on the left hand side or the negative side. And then if I think about the other direction, as this continues to drop and go out this way, again it might take a while to get out here to some of these larger x values, but it'll eventually get there because it is continuing down and to the right forever. So the domain here would be all real numbers. Okay. Now our range, however, and again remember that the range is our y values. Now the range here is not going to be all real numbers because you notice that we have this U shape and it kind of comes up here and then it drops back down. So the highest our U is going is right here, which for us is going to be -2. Now it continues to go on down forever and ever, so since it's going down, that is negative infinity. Now again, when we write our interval notation, we have to write the smallest number first. Well, that smallest number is how far down this graph is going as far as the y value is concerned, and that would be negative infinity. So we would have negative infinity. We use a parentheses because we always use that with our infinity symbol, comma, and remember our u stops and turns back around at -2, and we would use a bracket at -2. Okay, so for our next example, we're asking the same two questions. First, we want to know, is this graph a function? Again, thinking of that vertical line test, taking our piece of paper and sweeping it across, but look, notice right there on my graph, my line is touching my circle twice. The second I get one vertical line that touches my graph twice, this is no longer a function, so that would be no, we don't have a function. Alright, so now let's talk about our domain. Again, remember, domain are our x values. That's left to right. So notice we are working with a circle. So the furthest to the left it goes is right here. And that looks like that's going to be -9. And then the furthest to the right it goes is right here. And that's going to be -3. So our domain would go from -9 to -3. And we would have a bracket on both sides. And then looking at the same thing for our range, remember our range is our y values, that's up and down. So notice that our circle starts here right here at the x-axis, which in our case is going to be 0 for our y, and then it ends up here, and that looks like it's going to be 6. So our range, again, remember, always starting with the smallest value, in this case the bottom of your circle, and going to the highest value, the top. This would be from 0 to 6. And again, we would have a bracket at both 0 and 6.